Good morning, everybody. Let's take a look at, there we go, lesson 5.3. Okay, so we're going to talk about when we are given a graph of the first derivative, how we're going to answer questions. Oh gosh, this is the tricky part, guys, with justification. So we've talked about this a little bit in class about the, most hated words in AP Calculus are justify your answer, 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 okay? And the biggest reason is, okay, so when you guys can kind of read through this here. Okay, an extremely common type of FRQ on the AP Calc test is one where a graph of a first derivative is given. Notice this is the graph of the first derivative, not the function. Students are asked to make conclusions about the original function with justification. It's very important that students reference the given graph by name in their justifications. You know what this graph's name is? F prime of x. Typically, these justifications require a short sentence. It's unnecessary and unwise to write more than one sentence. If you justify correctly, but you continue by writing a false statement, the justification point is lost. This is important. So you usually will get a point for the answer and a point for the justification. Okay, it says many students find it helpful to draw first or second derivative number lines, sign charts. We're definitely going to do that, but they don't count as justification. They're just going to help us answer the questions. Okay, so let's kind of see how this works. All right, so it says the graph below is f prime, the derivative. It has horizontal tangents at 2 and -2. So you guys, that's where the derivative equals 0. And its domain is -infinity to infinity. On what open intervals, that means the -infinity to infinity, okay, is f increasing. Well, so I'm going to actually go ahead and make a sine line graph of f prime. And you kind of go like this. You say, okay, remember we get our critical points, and the critical points are where the derivative, let's write this down, the derivative equals 0. Well, in the case of this graph, this is the derivative. If I look through here, where does the derivative equal 0? Well, here at -4, here at 0, and here at 4. And then I do test points, right? But remember, we were plugging our test points into the first derivative. So, for example, if I test -5, I would get a negative number. If I test -3, I would get a positive number. If I test like 1, I would get a negative number. And if I test like 5, I would get a positive number. So it goes like this, decreasing, increasing, decreasing, increasing. My original function is going to look like that, okay? So here's how I write this up. I say f is increasing on the interval -4 to 0 and 4 to infinity because, now this is where we need to have our justification, okay? And how did we know from here that it was increasing? Well, because there was a positive on my graph, and we have to reference this by name. So we say because f prime of x is positive on those intervals. You could just say f prime of x is positive, like that's fine. Okay? But that sentence right there is worth a point. The answer is worth a point. Okay? So you got to be really careful about making sure you write it all perfectly. Okay, some big mistakes here. If I ask you to justify and you say it, that's bad. We can never use the word it, okay? Or right here, it is increasing. Like what is increasing, okay? So you have to use f, f prime, stuff like that. Okay, let's see. Let's look at where's f decreasing, okay? So we're going to say f is decreasing on the interval -infinity to -4, 0 to 4, because f prime is negative. All right, you can use the typical abbreviations for increasing INC, decreasing DEC, stuff like that. Okay? Okay, at what x value does f have a relative maximum? Okay, here we go. You guys can see there's a relative max right here at 0. So f has a relative max at x equals 0, right? Because, now here's how you write this. It's not because it's at the top of the graph or because it makes a peak or something. You have to say something about f prime, right? So I'm going to say because f prime of x changes from positive to negative. F prime changes from positive to negative. Okay? At what x values does it have a local minimum? So f has a local min, relative and local mean the same thing. Okay? At x equals 4 and x equals negative 4, because, so you can see them right here, the derivative f prime of x changes from negative to positive. Okay? So that's increasing, and you're basically just stating like how you know. You just have to write that sentence. Now, the next thing it talks about concavity and points of inflection, okay? I need to make a sign line of the second derivative. Now, this could be a little bit tricky because your second derivative is the derivative of the first derivative. But just remember, derivative of the first derivative, but what word can we place derivative with? Slope. So slope of the first derivative. Now, my possible inflection points are when f prime of x equals 0. Where does the derivative of this equal 0? Well, it told us right here and right here, okay? So my possible inflection points are at negative 2 and 2. And you guys, we're looking at slopes. So here's this guy here, my snowboarder. And what's happening as he's going up the mountain? Those are positive slopes. And then he's sliding down the mountain. Those are negative slopes. And then he's going back up the mountain. Those are positive slopes. And so when I draw it in right here, it's going to be concave up, concave down, concave up. Okay? So here's how I would write this. On what intervals is f concave down? It's concave down. F is concave down on the interval negative 2 to 2. Because, now here's where this gets a little bit tricky, okay? I want to say f double prime is negative. Because that's why f double prime is negative. But we're not allowed to use that as a justification. And the reason we're not allowed to use that as a justification is because it didn't tell me anything about f double prime. It told me something about f prime. So why is it actually changing concavity here? Because f prime is changing increasing to decreasing. But I have to say it in f prime words. So I'm not allowed to say that. Okay? I am allowed to say f prime changes from increasing. Wait, sorry. This is not a changing from, that's inflection points. Okay, why is it concave down? I wanted to say f double prime is negative, but I can't say that. Instead, I was doing the next question. Okay, instead I have to say because f prime is decreasing. You could also say, okay, so you can't say f double prime is negative, but you could also say the slope of f prime is negative. So you always got to take it back into f prime, okay? That can be a little confusing. Okay, guys, so let's go ahead and see if we can write up this next one, points of inflection. Okay, so I can see from my sign line graph that negative 2 and 2 are points of inflection. So I could say f has points of inflection at x equals negative 2 and 2 because, now what you want to say is f double prime changes positive to negative or negative to positive. But we're not allowed to speak in f double prime because we don't have that as a, we don't have f double prime as something that we can go off of. I have to go back to f prime. So I would change these words. So what's f prime doing? F prime at those points is changing from increasing to decreasing. Okay? So I get rid of this, and I say because f prime changes increasing to decreasing or decreasing to increasing. You could also say because f prime has relative extrema, because whenever f prime has a relative max or min, f double prime has a slope of 0, okay, and it's going to be an inflection point. All right, last one. On what intervals is f decreasing and concave up? Okay, so it's concave up outside of -2 and 2, and it's decreasing below -4, so that would work, and 0 to 4, which I'll only be able to do 2 to 4. So below -4 and 2 to 4. Okay, below -4 and 2 to 4. So f is both decreasing and concave up on the interval -infinity to -4 and 2 to 4. Now let's think about this. How do I say f is decreasing? Because f prime is negative. How do I say f is concave up? Because f prime is increasing. Okay, because f prime is negative and f prime is increasing. Negative and increasing. Okay? Little bit tricky, but yeah, that's how we have to justify everything. All right. So we're going to take a look at some of these questions and make sure that we're justifying properly. Okay. Maybe since this video is so short, we'll do one together. All right, just so we have one other example. Okay. So this is g prime of x. So do this one. Let's see here, assignment 5-3. Okay. Let me go ahead and make a sign line graph for g prime. Okay, so g prime is 0. It's actually hitting 0 at 4 points. -3, 0, 2, 4. Okay, and below that it's negative because it's below the axis. In between here it's positive. Between here it's positive, and then it goes negative, positive, okay? So if I'm drawing this in, it's decreasing, increasing, increasing, decreasing, increasing, all right? On what interval is g decreasing? Okay, we say g is decreasing on -infinity to -3 and 2 to 4 because g prime is negative. And that's it. Okay, g prime is negative, makes g decreasing. Okay, cool. All right, next, on what interval is g increasing? G is increasing on the interval -3 to 2 and 4 to infinity because g prime is positive. At what x value does g have a relative min? There are 2. G has relative min at x equals -3 and x equals 4 because g prime changes from negative to positive. Okay? Now, for my next bit of work for D and E, I need a sign line graph of the second derivative. So I'll write like this, and I remember that the second derivative is the derivative of the first derivative, and I just remember that that's slope. And so where the slope is 0, all right, now it's kind of have some sharp corners and stuff there, but it can still be, like, it's still changing there. So at -2, 0, oh, forgot that one, 1, and 3. And if I think about my little skier snowboarder guy, he's going up the mountain, and he's going down the mountain. He's going up for a little tiny bit, and then he's going down for a ways, and then up. So I have all this concavity. All right? Okay, so let's see if we can write up D and E. Where's G concave upward? So G is concave up, negative infinity to -2, 0 to 1, and 3 to infinity. Because, okay guys, now we can't say second derivative is positive, even though that's what we want to say. We can't say second derivative is positive, but we can say first derivative is increasing. Okay, always take it back in terms of the first derivative. All right, and then for part E, where does it have inflection points? So G has points of inflection. You can call them POIs. At x equals -2, 0, 1, 3, because G prime changes. Remember, we can't say G double prime because that's not what they gave us. So we have to say in terms of G prime. G prime changes from increasing to decreasing. You could say and vice versa, or you could just say decreasing to increasing. Okay? So we will definitely be practicing more of these in class, but hopefully that made sense.